Hello, everybody. I want to teach us something new today. This is cosine, and we've already learned about tangent and sine, so cosine rounds out the first three trigonometric functions that we'll learn. Cosine sounds like sine. It's related to sine. So I've got a document here that I'll be posting. You have a link to your problem book online. This is the exact problem book that we use. Available to you online. So if you don't have your book with you, you can look online and look at these problems. But I'm going to copy them over to the whiteboard so that we can work them out on the whiteboard. So page 50, number 10. Page 50, number 10. It says, ask your calculator for the sine of a 56-degree angle. The sine of a 56-degree angle. And then for the cosine of a 34-degree angle. Okay, well, let's do that on my phone. 56 sine, on your calculator, sine 56, and this is 0.829037 blah, 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 blah. Big long number. All right, and then if I do 34 cosine, I get 0.2829037. That looks like the same number. How can I take the sine of something and the cosine of something else and get the same number? Does that make sense? Well, how are these two related? If I have a triangle, and it's a right triangle, and I have a 56-degree angle here, and I want to know its sine, that's opposite over hypotenuse, right? What's the measure of this angle up here? I know that all triangles add up to 180. I've already got a 90-degree angle, so that leaves me 90 degrees left over. And if I subtract that 56 off, I get 34 degrees. This is the 34-degree angle. So what do we call it? What's the vocabulary word when two angles add up to 90 degrees? It's not supplement, that's 180. It's complement. These two angles are complementary. So if I take the sine of one and the cosine of the other, I get the same answer. Let's think about that. For 56 degrees, I use the sine, and that's opposite over hypotenuse. But for 34, I said cosine. Well, how would I get the same number exactly? It's if I use this number and divide it by this number, right? That ratio would give me this same number up here. But is this side opposite to the 34? It's not opposite to the 34, it's opposite to the 56. It's actually adjacent to the 34. So the cosine of 34 is the same, and that means we're using adjacent over hypotenuse. And there's our new lesson today. Cosine of an angle is adjacent over hypotenuse. So let's look at the second part of this question. The second part has us try it again on another set of angles, and I don't know, do they work out as well? This says, ask the calculator for sine 23 and cosine 67. Sine 23, 39073, 1128, it just keeps going. Cosine of 67, that's 67, cosine, 0.39073112884. I mean, it's not even close, it's exact. It's exact. And what do these two angles have in common? If I add them together, carry the 1, they are complementary. So complementary angles, you can use the sine of one and the cosine of the other. You'll get the same answer every time. And in fact, right here, the abbreviation of sine and complement, cosine, complement of the sine. Complement of sine is cosine, cosine. And we do abbreviate it COS. COS. Cosine of any angle is the adjacent side divided by the hypotenuse. Okay, so now when we have a hypotenuse in the problem, we need to think about, are we looking at opposite or adjacent related to the angle we're talking about? Because now we have the opportunity to use cosine if we know the adjacent and the hypotenuse. If we know the opposite and the hypotenuse, that's sine. If there's no hypotenuse involved, that's tangent, all right? So let's look at the next problem on my sheet here. 50.5, if you're following along. 50.5, that's page 50, number 5. And I'm copying that here so we can work on it together. A 25-foot ladder is leaning against a wall. Okay, already I need to draw a picture. I need a picture. I got a ladder, it's up against the wall. Here we go. Here's my ladder up against the wall, and I'm assuming that we've built our house appropriately and that the wall is perpendicular to the floor. So here's my ladder. On the ladder. All right, there's my ladder. It's leaning up against the wall. Now this says this is a 25-foot ladder. Remember, one little hash mark means foot, two of them mean inches. 25-foot ladder. It's leaning against the wall and makes a 57.32 degree angle. That's very, very precise. 57.32 degrees is my angle there. 52.37. How far from the wall is the base of the ladder? Well, that's this distance right here. We're going to call X. So our angles here, opposite would be the wall. This would be opposite, yes? So this is adjacent. The adjacent side of this triangle is the one that touches the angle. And this length of the floor here touches my 57.32 degree angle. So in this case, we need to use a ratio that says adjacent over hypotenuse. And that is our new ratio. Cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So you need to remember that. Sine opposite over hypotenuse, cosine adjacent over hypotenuse. Okay, and in your study sheet in the Word document that lists all the homework, there's a mnemonic that you can try to remember that will help you remember which one's adjacent and which one's opposite. So we can go over that at the end. But for now, we know that X is the adjacent. So am I using sine or cosine? I'm using cosine. Cosine of 57.32, I'm wondering how they got that precise, equals adjacent, that's X, over hypotenuse. We know the hypotenuse is 25 feet. So I'm going to multiply both sides by 25. Always multiply by what's on the bottom. Get rid of it. Top and bottom, 25, cancels out. Now I have X by itself. X equals 25 times the cosine of 57.32 degrees. So on my calculator, 57.32 cosine times 25, and I'm using my phone, so I had to put the degrees in first. And that equals, if I round it up to a tenths place, 13.5 feet. 13.5 feet. So the ladder, the bottom of the ladder is 13.5 feet away from the wall. Now it says without using trigonometry, try to predict how far from the floor a step on the ladder would be that's halfway up the ladder. So if we just go halfway up the ladder, we're halfway up the ladder. How far from the floor? How far from the floor is a step on the ladder? That's that question mark. What would it be? We know that this would be 12.5 if we're only halfway up the ladder. So how would we find it with trigonometry? Well, with trigonometry, we know this is what? Opposite or adjacent to 5732? It's opposite. It's opposite. So sine of this angle equals x over 12.5. So 5732 sine times 12.5 x equals 10.5. So even though we went halfway up the ladder, we did not necessarily go halfway in, or we actually would go halfway in. We didn't necessarily go only halfway up. We didn't necessarily go halfway up. And the same goes, if we only go 8 feet up the ladder, our hypotenuse is changing, but where would we be then? How far from the ground? We're again going to use sine, right? Opposite over adjacent, I'm sorry, over hypotenuse, opposite over hypotenuse, that's x over 8 times the sine of 5732. So read through this one again, do the work again so you have it in your notebook. This is a good example. Okay, the last one that I want to look at is on page 51. Page 51, number 3, and I'll paste it over here so you can see it. In a right triangle, the 58 centimeter hypotenuse makes a 51-degree angle with one of the legs. Okay, I smell a picture. It's a right triangle. It's got 58 centimeter hypotenuse. And it makes a 51-degree angle with one of the legs. Well, it didn't tell us which one. I'm just going to pick this one. 51 degrees. And it wants to know, to the nearest tenth of a centimeter, how long is that leg? So it's asking for the leg that this angle is touching. Well, if the angle is touching, that's the adjacent, right? That's our x. How long is that leg? Well, if it's adjacent and we know hypotenuse, that's our new ratio. Cosine of our angle equals adjacent over hypotenuse. So I'm multiplying both sides by 58, multiply by what's on the bottom. So those cancel out. I've got 58 cosine 51 degrees equals x. And on my calculator, and I'm using a phone, so 51 cosine times 58 equals, x equals 36.5, wait, it says to the nearest tenth of a centimeter. Nearest tenth of a centimeter. Nearest tenth of a centimeter, nearest tenth, all right? Nearest tenth, I'm gonna then look at my calculator. It says 36.5000. So it is 36.5, tenth is one place. centimeter. Now we've got this leg then. This is 36.5. How do I find this other leg? Let's call it y. I got two ways off the top of my head. How can we find y? Well, y is which part of the triangle with respect to that angle? It's the opposite, right? What is the opposite over adjacent? Opposite over adjacent is tangent. I could say tangent 51 equals opposite, and now I know the adjacent's 36.5. So I could figure it out that way. I could work that out and figure out what y is. Tangent of 51 times 36.5. I got 45.1, if I round it correctly, 45.1 centimeters. Well, I also know the hypotenuse. So what's opposite over hypotenuse? That's sine. What if I said the sine of 51 equals y over 58? Can I do that? Yeah, that's opposite over hypotenuse. So sine of 51 times 58 is, believe it or not, 45.1 centimeters. When I round it, it's the same. What's the old school way of getting this number? The old school way could be our good old Pythagorean theorem. Right, in this case, I know the hypotenuse, so 58 squared equals my 36.5 squared plus y squared. So if I take 58 squared and subtract out my 36.5 squared, I get that y squared equals 2031.75. So if I take the square root of that, y equals 45.1 centimeters. So once you know two sides of the triangle and you know an angle, you're golden. You can find that other side numerous ways. And now that you know how to use cosine with adjacent over hypotenuse, you've got all the tools you need to solve any triangle. So I'm going to go back to then the document that I have available for you. And just see, we've got a problem that has both sine and cosine together. So you'll first look at sine, and then they ask you to solve another problem using both sine and cosine. And then there's a series of 6 problems. Decide which side is opposite, which is adjacent to the given angle, and then determine which of the 3 trig ratios you would have to use. Is it tangent? Is it sine, or is it cosine? And then solve that problem. Write that sentence. I want to see that sentence. And you can do these in your notebook. It will not be graded, but it is good practice for you for today to make sure that you understand sine, cosine, tangent, and how they're all related. So you'll have access to this document, and you can rewind this at any point to go back and see how we work these first 3 problems, but you do want to put these in your book as well. Remember, you get to use your notebooks on the test, so as much information as you have in there is as possible is good for you. All right. If you have any questions, drop me a comment and I'm happy to reply, or you can pop into office hours on Wednesday. Have a great day, everybody.